Okay. Now I think we got it. Okay. So 3-6, we're going to solve radical equations. So basically that means that we are going to be looking at anything with a square root or a cube root, and we're going to be able to try and isolate that cube root. So there's two kind of keywords that we've got to fill in on our packet, and that is, let me grab my pen here. We are going to isolate, which is just a really fancy word for get it by itself. Isolate the radical expression on one side of the equation. So I have an example kind of working out here. So here I've got this equation. So the first thing they did is they moved their 6 over. They just added 6 to the other side so that they can isolate the radical. That's step 1. And then step 2, eliminate the radical or rational exponents by raising each side of the equation to the same power to get a polynomial equation. What you do to one side, you do to the other. So here we have this equation. So what they did is they raised both sides to an exponent. They squared both sides, just like you did in geometry. It's the same thing when you're doing Pythagorean theorem. A squared plus b squared equals c squared. You get, get your numbers and you square root both sides to get rid of the square. Well, to get rid of a square root, you're going to square both sides. So, and that will then cancel the square and the square root. That's how we end up with just this 5x plus 1. And then on the other side, we have 6 squared, so we get 36. And then we just continue to solve like normal. And then the other thing that I have here, if a to the n and a to the n equals b to the n, so if they have the same exponent, that's what this is trying to say. Same exponent, then that means the bases are equal. So if I said x squared equals 3 squared, then that just means that x equals 3. It's just a shortcut. So rather than trying to square root both sides, I mean, you can. It's just a shortcut to try and make the answer come up faster. Okay. So let's go through these. We got a couple of them. I have 2 of each type. And then there's one that is the solving with your calculator, which we kind of did the other day on Desmos. So we'll do that. I know all of the directions got cut off, but I can add those in or write those in. The graphing calculator directions are much more complicated than the Desmos directions. So it's actually a good thing they got cut off. Oops. Oh, I hit the wrong button. Let me undo. Yes. Okay, there we are. So solving a simple radical equation, basically what we had just come up with, we're going to go ahead and move. Actually, we could do this a couple of ways. I could move the 5 to the other side and then divide by the negative, or I could just add my 4th root of x to the other side. That way it automatically becomes positive. And since it's just adding to 0, it's not really going to affect anything. So that was my first step. Step 1, isolate. Step 2, eliminate. We want to eliminate the exponent, or in this case, our radical. So if I have 5 equals, I'm going to rewrite it here just for kind of prosperity's sake, I guess. If I want to get rid of the 4th root, then I'm going to raise it to the 4th power. Just like if I wanted to get rid of a square root, I would raise it to the 2nd power. If I want to get rid of a 4th root or a 3rd root, I raise it to the 3rd power. 4th root, I raise it to the 4th power. 5th root, I raise it to the 5th power, and on and on and on. So by doing that, that means I have to figure out what is 5 to the 4th power. So, like, what's the fastest way for me to get my calculator in here? Here we go. Oh, too big. Minimize that a little bit. Okay. Oh, that's right. This darn thing comes up. So I want to do 5 raised to the 4th power. So let me do that one more time for you guys. So 5, my raised to is that AB button. If you have your own calculator, the little blue calculators and the graphic calculators, it's the little caret button, in case we've forgotten. But in the Desmos, it's that AB, and then we just put in our 4. And it gives us our answer right there, 625. So boom, 625 is 5 to the 4th power. The x to the 4th and the 4th root cancel out, and there's your answer. Done. So the next one is basically the same thing. So if I want to, I got to move myself over here. There we go. I wanted different colors. I want to isolate. So step 1, isolate. So I need to get rid of that 6. The cube root of x is already a positive, so I'm not going to move it anywhere. So now I've isolated. That's my first step. Done. Step 2, I need to eliminate. That's really the big steps. That's the whole idea behind this. So if I have my cube root of x equals 6, then I'm going to raise both sides to the 3rd power. So that way the cube root and the 3rd power, the exponent, cancel each other out, and I just have to figure out what 6 to the 3rd power is. So if I do 6 AB raised to the 3rd power, boom, there's my answer, 216. And I'm done, because I don't have anything else there's nothing else to do with x. So those are our simple radical equations, and they're pretty simple. Oh, I gotta keep moving myself all over the page here. All right, so that wasn't too terrible, I hope. Let's try another one. What if they have exponents instead of a radical sign? They're still done the same way. Isolate, eliminate. So if I want to isolate, right now, this is really saying, so the exponent is only on the x, it's not touching the 3, or there's no parentheses. So this is kind of what it looks like right now. I have 3 times x to the 4th third power. So what I need to do is isolate, so I need to get rid of the 3. If there were parentheses around the 3 and the x, then I couldn't get rid of the 3. But because there's no parentheses, I can go ahead and just isolate, get rid of that 3. So I have to do 243 divided by 3. So 243 divided by 3. And I get 81. So that gives me x to the 4 thirds equals 81. So that was my step 1, isolate. Step 2, eliminate. I need to get rid of the exponent. I'm going to rewrite that up here just so I have it. So I isolate by dividing by 3. You don't have to rewrite these over and over again. I'm doing it just so that we kind of get the 2 big ideas, the 2 big concepts in our brains a little bit. So to eliminate, if I have x to the 4 thirds, I need to get rid of the exponent. And it's a fraction. So to get rid of a fraction in one fell swoop, we do the reciprocal. So in this case, I'm just going to raise both sides to the 3/4 power. Because I use a reciprocal, and I'll even write that in here. Reciprocal, use, let me see if I can move that guy over a little bit. Use a reciprocal to eliminate the fraction. Okay. There we go. All right, so the reason we want to do that is because my 3 times 4 on the top would be 12, 3 times 4 on the bottom would be 12, so really this gives me x to the 1st, which is just x. So we've eliminated the exponent, and now I can just type this into the calculator. So 81 raised to the 3/4 power. 81 raised to, so that's my AB button, 3/4, so 3 divided by 4. And boom, I get this nice little answer of 27. I can't say they're always going to be whole numbers, but we try to give you as much as possible a whole number so that it isn't as scary looking. So on the next one, it's just more of the same. So I'm just trying to give you guys lots and lots of examples so you can kind of see, Here again, there's no parentheses, so that means I can go ahead and get rid of the 2. So I have x to the 1/4. 8 divided by 2, we get 4. And then here again, I'm going to eliminate the exponent. So I'm going to raise to the 4/1. Okay, remember that this is an exponent. This is probably the biggest thing I see people do, the biggest mistake I see people make. They do everything right. They eliminate the 2 in front. They put the fraction, they do the reciprocal, but then they do 4 times 4/1 instead of 4 raised to the 4/1. So remember that that fraction is actually an exponent, and it might just be, it's hard to write some of the numbers really small. So I want to do, let me clear these, 4 raised to, and you could type it as 4/1. It's not going to change anything. And I get 256. So remember that that exponent, that fraction is your exponent. Okay. So now we're going to see, oh yeah, no, we don't give you guys any, oh, you guys are in luck. You guys don't get any ones where you have to do factoring. We took those out. College prep has to do factoring. You guys don't have to. You're good. Okay. I'm trying to figure out which camera I have a webcam that's on my Google Meets, and I'm trying to figure out if the webcam, oh no, it's my computer camera is the one that's on this one. That's why it looks funny. Anyways, all right. I have 2 different cameras running apparently. Good times. Make sure I've got everything the same here. Okay, so same deal. More square roots, more radicals. So we are just trying to get our radical by itself. So again, big steps, isolate, eliminate. So I need to isolate the radical. So here's my radical. So all of this has to be kind of grouped up. I need to get rid of that -4. Since the 4 is not inside the radical, I can move that over. I can't do anything with the 2 or the 8 right now because they're inside the radical. So I still have my square root of 2x plus 8 equals, now I have 6 plus 4 gives me 10. So I've done as much as I can at this point to isolate the radical. Now I need to eliminate it. So if I have the square root of 2x plus 8 equals 10, I need to raise a square because that's going to get rid of a square root. So that way those go away. So now I'm left with 2x plus 8 equals 10 squared, which is just 10 times 10, which we all know is 100. Now, in all of the ones we've done previously, we didn't have anything else in the radical or in the exponent, so we were done. But these ones we have to then just solve the rest of the way. So finish solving. So this one technically has an extra step. We got to finish solving. So we're going to go ahead and just subtract 8. So we get 92 and divide by 2. And I believe that's going to give us 46, but I'm going to double check. 92 divided by 2. Yep, 46. Now, technically, you should check the answers to make sure that they are right. If we wanted to, we could double check this by plugging it right back in. I know I haven't done that because most of the problems have been pretty simple. But our original problem was 2x, so 2 times, I'm going to use, I guess I won't use the parenthesis because I can't get it. So I had 2 times our x, which was 46, plus 8. And then after the radical, I have a -4. So that's kind of, if I plug that back in, it should equal 6 for our final answer. And sure enough, there it is. We got a 6. So we can see that if we plug it back in, the answers should match. Way up over here. There we go. All right, so then same thing, isolate, eliminate. We're just going to move our 5 over. Cube root, x plus 3 equals 7 minus 5. We get 2. And then in order to get rid of the cube root And here again, you guys do not have to rewrite it twice like I am. I'm doing it because it's easier to read on notes. I'm raising it to the third power this time because I have a cube root, so I need my exponent to match my radical. So now I have just x plus 3 equals 2 to the third, 2 times 2 times 2, which would make 8. And then for the last step, I'll just subtract that 3. Boom. Not too terrible, I hope. Going pretty quick on here. Alrighty. All right. Last little bit, solving with two radicals. And then I'll do, I'll kind of go through and show you guys how to do these in Desmos too, on the graphing calculator Desmos. So here we notice that we have two radicals. So if I want to isolate the radical, that's step one. Oops, can't put myself there. There we go. If I want to isolate, well, this radical, it's already by itself. And this radical, it's already by itself. So my next step would be to eliminate. So I've already isolated. So I'd need to eliminate, which would mean I'd need to raise fourth root, I guess, of 5x minus 10 equals fourth root of 3x plus 12. They both are raised to the fourth power. So if I raise the left side to the fourth power and I raise the right side to the fourth power, both of the radicals are going to eliminate themselves. And this is that extra little thing that I showed you guys at the top of the page, that if they're the same exponent, and in this case an exponent and a radical are the same thing, if they're the same, then they're just equal. Since these were the same, it was a fourth root, and there was nothing else there, well, that means that the part inside is also just equal to each other. So now I can just solve. This is just a basic T-chart my equation, and we move on through. Subtract my 3x, I get 2x. I'm going to go ahead and add my 10. So I get 22, which means that x is 11. I'm going to write divide by 2 here just so that we've got those little steps. Here again, we could double check. Checking this one is actually a little bit harder because, let me clear that. So I have my fourth root, so I'm going to push my little radical, my n root, fourth root, 5x, so we're saying 5 times 11 minus 10 is in one side. So I get this decimal, 2.59. I need to make sure that the other side, the fourth root of 3 times x, 3 times 11, plus 12, gives me the same answer. And sure enough, it does. I can see these are the same. So when I plug it in, I know that my answer is correct. So you can absolutely check to make sure you're doing them right. Last one of these, real quick. Well, so we want to isolate. Whoops, my phone's ringing. Oh, crud. Hold on one second. I'm going to mute. My son's school is calling. That's never good. Whoop. Hello? All right. Oh, let me unmute myself. So his teacher had to go get a COVID test. My son's teacher had to go get a COVID test. So his whole classroom's now quarantined. Oh my gosh. Okay. Well, I told them, I'm like, I'm in the middle of a lesson right now. Can I come get him in like after that? And they're like, yeah, it's fine. I'm like, they're all just hanging out in the classroom because they have a substitute teacher, and oh my gosh, what a mess. Okay, so let's finish this last problem. I gotta stay focused here. All right, if I'm isolating, I need to get my 2x, my radical 2x. I'm just going to add that over to the other side. Keep the radical on it. Okay, so I have square root of 4x plus 28 equals square root of 2x. And then it's the same thing as the other one. They're both square roots, so I can raise them both to an exponent, which really just means that they're equal to each other. This one looks a little weird because when I go in and bring this over, I get 28 equals, I'd actually have to get a negative 2x, and there's an issue there. If I divide by a negative, I get a negative 14 for my answer. And that's an issue because remember we said these were in square roots. They're in even roots. So if I try to plug in, let's see. Oh, why does it say I lost my connection? My internet looks fine. Of course, because I'm going to keep recording. Clear. It might come back. It looks like you guys can still see me. It just is that my Google Meet looks funny. Let me ask. I'm going to send a little announcement and see. Because I can't, it doesn't show on my Meet that I have you guys here, but it shows that I have you guys here. Let me try something. You know, we were doing fine, and now we're not. Oh, looks like I lost that. Hold on. Hold on, I'm trying. Oh, okay, I got you back. All right, I was just gonna send, like, it's not the internet, it's the computer. Because the other computer is working fine. I was just about to send everybody an announcement like, can you still see me? Can you still hear me? I don't know. Sorry, my bad. Let's see. Let me present. I'm like, we're on the last problem. We're so close. Okay, and then is my Screencastify still Screencastifying? Yes, it looks like it is. Okay, so let's try that one more time. So I have a negative 14 for my x. So that's an issue. So, and that's because these are square roots. So let me clear this. So I have square root of 4 times negative 14 plus 28. And what do you notice I get for my answer when I plug it back in? It's undefined, meaning that you can't square root a negative. So because of when we check, we actually end up with no solution, no real solution for this. So we do have to be a little bit careful, especially when you get negatives, to watch out for those. I'm trying to look here really quick to see on our answer key. Do we get any of those in our homework? We do. We get a couple of them in the homework too. So hopefully that will help you to realize that you're going to have to see those a couple of times. Not often, but a little bit. Also, when we look at this, let's go ahead. I'm going to grab up my Desmos, my graphing calculator, and I'm going to show you guys how this looks on the graphing calculator too. So I'm going to do a couple of things, make a few modifications to my graph so that we can see this a little better. So here's my graph, and I had the square root. Oh, that's right. Oh, okay, I just can hide the tools. I didn't know I could do that. So I need to do my square root, there's my square root of 4x plus 28. And then I'm going to have my square root of 2x. And I'm going to make this bigger so we can see it. And if I look, We said our answer was supposed to be negative 14. Well, negative 14 is over here. I don't have anywhere where these graphs are ever going to cross. You see that? They just keep getting farther and farther and farther away. So there is no solution, because just like when we think about graphing y equals mx plus b, when we graph two linear equations, their solution is where they cross. That's the same with these as well. So we don't have a place where the graphs actually cross, so we know there is no solution here. So it's kind of an interesting little deal. So that's what the next part of our notes is being able to do this in a graphing calculator. So we're just going to use our Desmos calculator. So it says type both equations into the calculator. It says y1, y2. On Desmos, we're just going to do our two equations here and here. So we're going to type the first one, which was, let me flip the page here. I have, I'll make sure I have the right thing. Yeah. In parentheses, so I'm going to put my parentheses, 1/5. So 1 divided by 5. Oops, probably would help if I typed in here. 1 divided, nope, try that again. Divided by 5, 1/5 x. And then I need to raise it to, so I'm going to use my AB button again. AB, 3 divided by 4. Oops, 4. So I get this really kind of low-key, slow slope to that graph. My other graph I have is x minus 3 divided by 8. And we can look, if we see here, we get these two graphs, we zoom in on them, we can see that they are in fact going to cross. And that place that they cross, Desmos already highlights for us. And so then we can see that what our solution is. The x value of the point is our solution. So our x value would be like 0.57. Boom, done. There's your answer. So I'm going to write graph both on Desmos. The place they cross is the answer. Use just the x value. So for us, x equals 0.57. I will show you guys, because I know some of you have your own graphing calculator, and when you do eventually take the SAT, they're not going to allow you to use Desmos graphing calculator. They're going to expect you guys to use one of the TI-84s or another version of that. So I'm going to show you really quickly here how to do that in the graphing calculator, because it is a little more involved. There are a couple of buttons that we have to push because it doesn't actually pinpoint. Our graphing calculators aren't touchscreen, so it doesn't pinpoint it quite as nicely. So what we would do in the graphing calculator is we're going to hit the y equals button. You might have stuff in here, you might not. And I'm going to type my two equations in. So I'm going to use my parentheses. I'm going to do my 1/5, just like I did before. My x button is up here next to the green alpha, or you could do alpha and then find the letter x down here. So either way. And then I'm going to close the parenthesis and I'm going to raise it to 3 divided by 4. If your calculator is one of the older, kind of bigger, fatter ones, it might not keep the 3/4 in the exponent, or it might have the caret symbol, and then you need to put your 3/4 in parentheses. And then our second equation was our x, so here again, next to my alpha, minus 3 divided by 8. Okay, so it's not going to look like anything really super fancy. I'm going to hit zoom 6. That's the standard window, so -10 to +10 on both directions. And I can see here, I've got my two graphs. It kind of looks like what we had before. Unfortunately, though, you can't really zoom in. Like, you can't use your mouse. In my case, I'm using it on the computer. You can't use your mouse. You know, if I'm trying to type this in on this calculator, I can't zoom in the window or anything. So if you need to, if you really can't see it, you can zoom in. However, you can also, you'd hit second and then trace. So, and it says it right here, Second trace that it's got the word calc right above it. And we're going to choose option 5. We want to know where do the lines intersect. So I'm going to choose option 5. And then basically you just have to press enter. You have to make sure that an equation comes up that you have an x and a y value. For the most part, you will. So, and it shows you, because this is a colored calculator, colored screen, it shows you the two different colors. That the blue line, we had some numbers. The red line, we've got some numbers. You can guess. You don't really have to. I'm just going to hit enter. And there it is. There's my intersection. So I'm going to drag and drop this over here so that we can see it. That's another kind of cool feature of that graphing calculator, is that it shows me where these numbers are. So I'm just going to slide this over. But that way you can kind of see you've got your x value here. I'm just going to slide that down. And that way when I print this for everybody who wasn't able to be here, you've got it. You can see it and look at it. So I know like Tori was having issues with her internet. Or if you're looking at it later on for your notes, or while you're taking a quiz or a test or something, then you've got this kind of as a reference. So here we go. Boom. Okay. Do they seem terrible? Hopefully not too bad. Again, no factoring that you need to do. I'm not going to make you guys do the my turn, your turn. I don't even think I have it on here. Nope. The on your homework, the 1 through 4, or just type it in your Desmos calculator. 5, 6, and 7 are check to see if the solution actually works, meaning just plug it into your calculator. So you don't have, you can solve it if you really want to. You could solve it and see if your answer comes up the same as theirs. That's one way to do it. Or you can just plug the 5 in. So like number 5 on your homework says, check to see if x equals 5 is the solution. So plug 5 into the x value and see if it works. See if it makes a true statement. That's all I mean by check the solution. Okay, I'm gonna stop. Ooh, yeah. No, I don't want to do that. I want to stop this.